To solve this root equation, we need to cancel the square root. So I'll start by just copying this equation down again. But I don't want to start by squaring both sides. Instead, what I'd like to do is subtract 9 from both sides, isolating the square root. I get the square root of x plus 3 is equal to x minus 9. It is at this point where I want to square both sides. And the left side is really simple. When you square a square root, you're left with what is underneath that square root. Now on the right, if we're squaring this, we do get x squared. You also get negative 9 squared, which is 81, but you get two middle terms, which is not positive. It is negative 18x. So just be careful about this. The reason for this is if you're squaring x minus 9, that's x minus 9 times x minus 9. We're foiling. X squared, you get a negative 9x. You get a second negative 9x, as well as a positive 81. Anyway, the goal is to now set this equation equal to 0 since we have a quadratic. So I will subtract x from both sides, as well as 3. It gives me 0 on the left. On the right, I have x squared minus 19x, and then it's plus 78. Okay. This looks like it'll be a little bit more difficult to guess the factors, but let's give it a try. It has to be x minus for both. I want to find two numbers that multiply to 78 and then add to a negative 19. I'm going to think about that for a second. All right, so after a little bit of work, I figured out that it's 6 and 13. I'll just double check this. So 13 times 6, if they're both negative, gives me positive 78, yet the sum is negative 19. This is helpful for us because, well, that means x equals 6 and x is equal to 13 are potential solutions. But the issue is with 6, it's not going to work. It is an extraneous solution. However, 13 does work in my original equation, and that is the solution to this problem. I started this problem by graphing the function into my calculator, being careful to use parentheses around the numerator and the denominator, and part A is trying to lead me through this process of solving an inequality. I'd like to identify the vertical asymptote, horizontal asymptote, x and y intercepts. There could be multiples of those. What we're going to need to do, though, is factor the original equation. So I'll do that next. So I'm thinking this thing factors for this problem to work out nicely. In the numerator, it's going to be x minus 1 and x minus 4. The product is positive 4 and the sum is negative 5. And in my denominator, it's going to be x and an x, a positive and a negative. It's got to be positive 2 and negative 3. The product is negative 6 and the sum is negative 1. Therefore, the vertical asymptotes of this equation are the places where the denominator is equal to 0, negative 2 and 3. So x equals negative 2, as well as x is equal to positive 3 are two vertical asymptotes. I'll draw those on my graph. Okay, the next thing is the horizontal asymptote. No surprise here that it's going to be 1 as the numbers in front of my x squared terms are both 1. So I'll mark this on my graph. The x-intercepts are where the numerator is equal to 0, which is going to be positive 1 and positive 4. So 1 and 4 for x give me 0 for y. And then the y-intercept is going to be what results if you put 0 in place of x. It's just the two numbers at the end of my equation. It's actually a negative number. It's 4 over negative 6, or if you'd like, you can just say it is negative 2/3. So just something that's getting pretty close to negative 1. Before we actually sketch the graph, I want to check to see if my graph crosses the horizontal asymptote. So all this stuff was part A. For part B, does my function, if I set it equal to 1, have a solution? And I think it is. I'm going to multiply this denominator to this side. This will change my equation to x squared minus 5x plus 4 is equal to x squared minus x minus 6. It's nice in that the x squareds cancel. This changes my equation to negative 5x plus, that's a 4, is equal to negative x minus 6. I think what I'm going to do is add 6 to both sides, as well as add 5x. When I do this, I get 10 is equal to 4x. If I divide both sides by 4, I'll simplify that. There's a factor of 2, so it's really 5 halves is equal to x. So there's a number where this thing crosses over the horizontal asymptote. It's approximately 2.5. I'm going to mark that on my graph. That's right here. And that's what my picture looks like. I see the equation goes through these intercepts, but also crosses over the horizontal asymptote. This is the only place where this happens. So over here, I know the graph is always below 1, and over here it's always above 1. Let me sketch that on here. So this is now part C, sketching my graph. This graph approaches the asymptotes and goes through my intercepts and crosses over the horizontal asymptote. Over here, the graph goes through the intercept and approaches the asymptotes. And over here, my graph is only approaching those asymptotes. All right, so now that we have the sketch of this graph, what I can do is identify where is my function less than or equal to 1. So answer part D. Here's 1, and the places where the graph is below 1 or equal to it are here and here. So I'm going to highlight those. All right, so that is this portion of the graph going right up and including that point, as well as all this stuff over here. So here's my answer to part D. Okay. It's going to be everything from -2 up to and including positive 5 halves, but also everything from 3 to positive infinity. And that is the final answer to this question. For part A, I'd like to find the inverse of the function f of x. My function is technically y is equal to negative x minus 7 cubed plus 10. But the inverse is x is equal to negative y minus 7 cubed plus 10. So it is this thing that is the inverse, which I now want to solve for y so I can express it as a function. I'm going to subtract 10 from both sides. This gives me x minus 10 is equal to negative y minus 7 cubed. So this is a little bit annoying that there's a negative in front of this, a -1. I could divide both sides by -1. There's nothing wrong with that, so I think I'll do that as my next step. And on the right, it's nice. You just get y minus 7 cubed. If you divide a negative into 2 terms, it just changes the sign of both terms in the numerator. So we get a negative x and a positive 10. So I'll put negative x plus 10. I don't know why I wrote it down there. I meant to write it here. All right, now I want to solve for y, but that cube is a problem. What I'm going to do is take the cube root of both sides. In doing so, the left is more complicated. It's the cube root of negative x plus 10, but the right is simple. It's y minus 7. If I now simply add 7 to both sides of my equation, I end up with this. I get the cube root of negative x plus 10 plus 7 is equal to y. It is this thing that is my inverse function for f. So that was the cube root of negative x plus 10, but then plus 7. I think the function g in part b will be a little bit easier. Again, my original equation is y is equal to 2x plus 5 over 7. And if I rewrite this as my inverse, it's x is equal to 2y plus 5 over 7. So here we have the inverse, which I'm now going to solve for y. I'm going to start by multiplying both sides by 7. On the left, it'll give me 7x, and this cancels the denominator on the right. I will now simply subtract 5. So I have 7x minus 5 is equal to 2y. And if I divide both sides by 2, I arrive at what is basically my answer. 7x minus 5 over 2 is equal to y. This represents the inverse for the function g. So that was 7x minus 5 over 2. Now for an equation like this, you could check your work by asking, well, what does this function do? The inverse should be the exact opposite of that equation. Like the first step here is multiply by 2. Over here, the last step is divide by 2. Here, the middle step is to add 5, and the middle step over here is to subtract 5. The last step here is to divide by 7, and the first step over here is to multiply by 7. I'm pretty convinced that this is my answer, and that is it for this problem. For part A, I entered my function into the graphing calculator, and I'm looking for the zeros. The graph that I see looks like this. It comes up, disappears a little bit, but I know it comes back down, and it looks like it only just touches the x-axis there, and this is the graph I'm seeing. So if I'm to guess the zeros, it looks like I have one here and probably just one here. It looks like -4 and +1 are my zeros. So I'm going to check that in my table. If I go to my table and look at -4, that's right. -4 makes my function 0. What about 1? 1 also works. So, all right, it looks like x plus 4 has got to be a factor as well as x minus 1. So that's, I guess, how this equation factors. X plus 4 times x minus 1. But I know if I multiply this all together, it'll not equal something that has an x cubed. So what's going on here? Well, if you look at this 0, it looks like a quadratic. Like over here it crosses versus here where it stays on the same side, an x squared. What I'm going to do is put an exponent of 2 on x minus 1. Making this my final answer here. So if I were to multiply all this out, this contributes an x squared. Multiplying this in gives me an x cubed, which would take me back to this equation. All right, let's try that idea in part B. So again, I'm going to my calculator and I'm entering my function, and let's go from there. All right, so the graph I see, okay, so again, disappears off my screen a little bit, but the graph comes up, goes back down, before coming back up. Not a great sketch, but I see there's a 0 here, and it looks like that's at -3 perfectly. The next one, it's not on an integer, it's between 0 and -1, and the next one is between 1 and 2. So, okay, I think I'm going to have to do a little bit of work to try to guess what these zeros are equal to. I'm going to start by checking -3. And I was right. -3 makes the graph equal 0. Nice. For the other ones, I'm going to have to do a little bit of guesswork by looking at this 9 and this 6. If I look at the factors of 9, that's 1, 3, and 9. If I look at the factors of 6, that's 1, 2, 3, and 6. Whatever this fraction is, it's a negative number. This will be a numerator for it, and this will be a denominator for it. So I just have to make the appropriate choice. So I know like -1/2 or -1/3 or maybe even -1/6 would be a possibility. I guess, try a couple of those here. Maybe I'll try negative 1/2. And when I do, I get 5. So nope, that didn't work. Well, I'll try again. I'm now going to try negative 1/3. And this one does work. So it might take you a couple of guesses, but you can eventually get there. The last thing is, now I need something between 1 and 2. Again, this is a numerator and this is a denominator, and there's not a lot of choices. Like, I think it's got to be 3/2 is basically my only choice. I hope that works. And it does. If I do 3/2, I get 0. I found my 3 zeros. From this one, I know x plus 3 is a factor. From this one, I know it's got to be x plus 1, and because there's a denominator 3, I'll put that next to the x. And here, this is going to be an x minus 3, but I have to put a 2 in front of the x. This thing factors as x plus 3 times 3x plus 1 times 2x minus 3. That's my final answer. And just to double check, 1 times 3 times 2 multiplies back to 6, and 3 times 1 times negative 3 multiplies back to negative 9. So here we're going to sketch 2 transformations based off of this original graph. And if I look at this function, I see there's like 3 differences. There's a negative, there's multiplying by 2, and then there's this 0.5 in front of the x. So I'm going to write this down as 3 steps. In terms of order of operation, I'm going to work within the function, the parentheses first, and I see we're multiplying this x by 0.5. And you might think that is to take half of the x's, but actually that's going to do the opposite. It's going to double the x values. The second step, I'm going to treat it as this negative. I know if you multiply a y value by a negative, it's going to reflect it. And technically that's over the x-axis. And then the last thing this function does is multiply by 2, which will double the y's. With that information, I'm going to run these 3 points through these 3 steps, starting here. Okay, the x is currently at -5, and if I double it, it goes to -10. Since it's on the x-axis and I reflect it, it doesn't go anywhere. And if I double it, the same thing happens. Steps 2 and 3 don't change this point because the y value is 0. So what I'm going to do is mark that as my point. Okay, this one has an x value of 0. If I double it, nothing happens to it. If I reflect it by multiplying it by -1, it goes to -5. And then if I double that, it goes to -10. The last point is this one, which is at x is equal to 3. If I double it, it goes to 6. The y value is 5. If I reflect it, it goes to -5. And then if I double that -5, it goes to -10. And then this is my function. It doubled the x's, it looks like it did. It is definitely upside down, and then it is stretched in the y direction. Okay, this is a little bit easier. It's only 2 steps for this one. This is fantastic. Okay, I'm changing my x's. I'm seeing x plus 5, but I know that doesn't mean go right 5. Instead, it means it goes left 5 places. Now, this plus 5 at the end is outside the function. It's changing the y values. It'll do exactly what I expect, which is to go up 5. I will go back to my original function and run these 3 points through these 2 steps. If I first go left 5, I go here. If I then go up 5, I end up at this spot here, -10, 5. All right. This goes left 5, and then up 5. Well, this one's easy. And then this one, if I go left 5 and up 5, I end here. And that is it for this problem. For this problem, I defined my variable to be the liters of the 5% acid solution. To solve this problem, on the left side of my equation, I'm going to write down what I'm mixing together. There should be 2 terms, each of which is a percent times an amount. So to start with, 5% times x, that's the amount of acid in the thing that I'm pouring in. I'm mixing this with 2 liters of a 90% acid solution. This is the amount of acid being contributed from the 2 solutions being mixed together. On the other side of my equation, I want to write down what I end up with, and it's going to be 0.89 times x plus 2. Again, a percent times an amount. I now need to solve this equation. All right, so let's get started there. I can't do anything with the 0.5x. Now 0.9 times 2 is 1.8. And if I distribute the 0.89 to both terms, if I double 0.89, I get 1.78. I think I guess I'll subtract 1.78 from both sides of my equation, as well as subtract 0.05 x from both sides as well. And when I do that, on the left, I get 0.02 is equal to, and on the right, I get 0.84x. I now need to divide both sides by 0.84. All right, I'm going to do that. Just checking my work on my calculator here. Wow, okay, so I get an answer of, I'll have to round it, but 0.024x. And that's actually not a surprise. I was not decreasing the concentration of acid by very much, and the thing that I'm pouring in is so low in acid that would help make the value even smaller as well, but this is the final answer to the problem.